So, the last part of our notes that we want to go over is intermolecular forces. So, what exactly does that mean? An intermolecular force is the force between the molecules. It is the force with which molecules attract each other. Now, it is just that. It is a force. It is not a bond. Now, some intermolecular forces are super, super strong, and the intermolecular force is responsible for the physical state of a compound. So if there are really strong intermolecular forces, the compound is more likely to be a solid. Slightly weaker would be a liquid, and almost non-existent is going to be a gas. And some examples of intermolecular forces that we're going to talk about are hydrogen bonding and van der Waals forces. So I just want to emphasize, hydrogen bonding is not a real bond. Hydrogen bonding is a force between molecules. It is the strongest of intermolecular forces, but it is not a bond.
What are hydrogen bonds? An attractive force called a hydrogen bond can exist between certain molecules. These bonds are weaker than ionic or covalent bonds because it takes less energy to break these types of bonds. However, a large number of these bonds going on can exert a strong force. Hydrogen bonds are the result of an unequal charge distribution on a molecule. These molecules are said to be polar. If we look at a water molecule, we can see the oxygen atom shares electrons with two different hydrogen atoms. So, in total, this molecule has 10 protons, 8 from oxygen and 1 each from the hydrogen atoms, and a total of 10 electrons, 2 shared between the oxygen atom and hydrogen atom number 1, and 2 shared between the oxygen atom and hydrogen atom number 2, and the other 6 non-shared electrons from the oxygen atom. So, this water molecule is electrically neutral, but it has a partial positive side, the hydrogen side, and a partial negative side, the oxygen side of the molecule. The electrons are not shared equally within the molecule, as they have a higher probability of being found closer to the nucleus of the oxygen atom, giving that end a slightly negative charge. So the hydrogen atom's end of the molecule will have a slightly positive charge. These charge ends weakly attach the positive end of one water molecule to the negative end of an adjacent water molecule. When water is in liquid form, there are a few hydrogen bonds, solid form, many hydrogen bonds, and when water is steam or gas, there are no bonds because the molecules are too far apart to form any bonds. Hydrogen bonds only form between hydrogen atoms that are covalently bonded to an oxygen, nitrogen, or fluorine atom. Hydrogen bonds are also important in the structure of proteins and nucleic acids, which we will cover in later videos. So now we know that water molecules are polar, or have a slightly positive and slightly negative end. And in fact, many lipids, or fats and oils, are not polar, so their molecules share electrons equally in their bonds. So these are non-polar molecules. This means that when water and oil come together, they do not form bonds with one another. Even when we try to mix them, the water molecules will eventually separate because their polar molecules are attracted to one another and will form hydrogen bonds, which will separate the water and the non-polar oil molecules. And that be the basics on hydrogen bonds. What are hydrogen bonds?
So, the hydrogen bond is the attraction between a hydrogen atom of a molecule to an unshared pair of electrons in another molecule. Now, these hydrogen bonds only occur in molecules where hydrogen is covalently bonded to a very electronegative element. So if you have a compound where hydrogen is bonded to nitrogen, oxygen, or fluorine, that is where you will see hydrogen bonding occurring. This is the strongest of all intermolecular forces, and it is possible because there is no shielding. So remember, shielding is the blocking out of the attractive forces between the nucleus and the valence electrons. Now, hydrogen, when its one electron is involved in bonding, There is no shielding. It leaves that entire nucleus wide open, and that positively charged nucleus is going to be attracted to the negative electrons that are on the other atom, that oxygen, that nitrogen, that fluorine. And it is responsible for physical properties of water and other biological substances. So if we look at just this quick example where you see hydrogen bonding in water, what you notice is the molecules are going to flip and turn so that the positively charged hydrogens are attracted to the negatively charged lone pairs of electrons on my oxygen atom. Now, van der Waals forces are my weakest attraction between molecules. It is the electrostatic interaction between the oppositely charged regions on polar molecules. So this is a dipole-dipole type of interaction. Now, a dipole is created by equal but opposite charges that are separated by a short distance. So when I have two atoms bonded together, or even just one singular atom where I have movement with my electrons, okay, we have a positive side and we can have a negative side depending on which way my electrons are moving. So temperating fluctuating dipole shows a full neutral kind of color, and if we have a polar molecule, we have a positive side and a negative side, and my electrons are going to move around, and that's why I see this induced dipole where I have this original dipole with a positive and negative side, and then the molecules are going to flip so that I have, or move, the electrons will move, so that my positives and negatives line up. So if I'm looking at, say, a solid, you can see that these have positive, negative, positive, negative. Once again, we see the same alternating pattern because, as we remember, opposite charges attract.